So we left off last Thursday talking about these complex trig applications. Then we talked briefly about triangles. So oblique triangles are a triangle without a right angle in it. So it might be something like this. There's an oblique triangle. Now if I label this triangle ABC for its vertices, we know that the sides are named by its opposite angle. So this would be side little a, side little b, side little c. We have also learned basic rules. Largest side, opposite, largest angle. And the other way around, smallest side's opposite, smallest angle. Take advantage of this relationship. There's a rule that allows us to make that comparison, actually find those lengths. They're not directly, well, they are directly related to the size of the angle, but not linear, not a straight proportion. They're related to the sine of their opposite angle. So that gives us law of sines. Now the law of sines can be written one of two ways. The way I usually write it is like this. The length of the side divided by the sine of the opposite angle is a constant for each triangle. It's different from one triangle to the next, but for all three sets of sides and angles for a single triangle, it is a constant. So the length of side B over the sine of sine B, or angle B, same as the length of side A over the sine of angle A. Same as the length of side C for the sine of angle C. Now many textbooks will have this the other way around. Sine of A over the length of side A. It's the same thing, it's just flipping your proportion over. That's all it is. Same relationship. So if I give you triangle, I'm trying to tell you that this angle here, 71 degrees, this side over here is 42 millimeters. Let's give us this angle down here of 44 degrees. So the first thing I have to find is I need the side and its opposite angle where I know both of the dimensions, the degrees of the angle and the length of the side. Here, that would be side C and angle C. 42 millimeters, sine of 71 degrees. For the rest of that proportion, then, there's only one other piece of information I have here, and that's the 44 degree angle down here. That has to go on bottom because that has to go with my other angle, the 71 degrees. Sine of 44 degrees. Which side am I going to be finding, or which side has to go above the 44 degrees here? Side little a goes above that. That is the opposite side. So now we can cross, multiply, and divide. So we're going to do, I got my mode set here for degrees. So now we'll do 42 times sine of 71. Now it's very important you close that parentheses. Wrong angle there anyway. 42 times sine of 44 divided by sine of 7. Gives me 30.86. This is 30.86 millimeters. So we found that other side. Now a quick comparison, this angle is bigger than this angle, so it makes sense this side is bigger than that side. So it makes sense so far. How do we find angle B? That most people overthink. It's just angle sum. We know two of the angles, so we know the third. 180 minus 71 minus 44 is going to be 5, I believe. Now, before we do any calculating, in reference to the size of the other sides, where do we expect this one to be? Smaller than both of them, bigger than both of them, or in between? In between. 65 is between 71 and 44. We're going to expect the length of this side to be between 42 and 30.86. Now I go back to that original side and angle that I had. I have 42 millimeters divided by the sine of 71 degrees. And now I have angle B, which is 65 degrees. Let me sine of 65. What side goes above it? B, good. And once again, we cross, multiply, and divide. 42 times sine of 65. Again, you got to make sure you close that parentheses. Divided by the sine of 71. 40.26. And once again, that makes sense. It is between the 42 and the 30.86. We were expecting it to be between those two because the angle is between. So we found those missing pieces. All triangles have 6 pieces. Triangles if we know 3 of them, with the exception of all 3 angles. We know all 3 angles, we know it's similar, but that's all we can really do with it. But if we know 3 of them, or we know at least one of them is a side, find the others. The example we just did was an example where we know 2 angles and one side, parentheses here, I'm going to put opposite. What does opposite mean? Opposite means that side was across from one of those angles that we were given. Here, the 42 millimeters was across from the 71 degrees. There's a second possibility where we know 2 angles and one side. The term is included. Included means between. So I might tell you that this angle here, 38 degrees, and this angle up here is 1 degrees. Side C over here, 0.45 inches. That side is included between the angles. We have to set up our law of sines, we have to have one side and its opposite angle. Here we don't have that given, but anytime we have 2 angles, we really have all 3, don't we? How do we find the third one? 180 minus 61 minus 48. Now that we have that third angle, now we have the side, the 2.45 inches, and its opposite angle, 71 degrees. 0.45 inches over 71 degrees. Somebody pick an angle, 61 or 48. Minus 61 on bottom. Which side goes with that? So we will cross multiply and divide. 0.45 times the sine of 61. Again, make sure you close that parentheses. Divided by the sine of 71. 2.2663. If you haven't noticed, when I do these, sides are tended to be calculated 2 decimal places past what's given. Same with angles. Now I can find, the first question, of course, is does that make sense compared to the 2.45? Yeah, because 61 is slightly smaller than 71, 2.26 is slightly smaller than 2.45. Find side A, are we expecting that to be smaller, larger, or in between? Smaller, because 48 is smaller than the other two angles. How are we going to set that up to find side A? So 2.45 inches over, where goes the other one? Perfect, little a over the sine of 48. Cross multiply and divide. 0.45 times sine of 48 goes the parentheses divided by the sine of 71. 1.9256. Does that length make sense? Yeah, it's smaller than the other two. Now I realize that's kind of a crude little comparison, and it doesn't catch every mistake, but it catches the big ones. Just making sure that the smallest side's opposite the smallest angle and all that. So those are the cases where we are given two angles and one side. Anytime we are given two angles and one side, we're good to go. So let's look at the cases where we are given, where we know sides and one angle. This case is way more complicated. I'm going to start out, this is obviously our third case here, where we have two sides and one angle. I'm going to put in that term again, included. Included means what? Between. I might give you angles A, B, and C, where I tell you that angle A is 39 degrees. Sides A, B, and C, where I tell you that B, 29 millimeters, and C is 35 millimeters. So if I'm going to draw this triangle, ABC, A here is 39 degrees. Here's 29 millimeters. B is 35 millimeters. Do I have a side and its opposite angle here? I do not. No. Can I find a missing angle or a missing side so that I have a side and its opposite angle? After we teach all this, it's hard to see. With law of sines, you cannot. Right now, you can't do that. This is what we're going to cover tomorrow, called law of cosines. I've had law of sines. We're going to cover law of cosines. You know, is there a law of tangents? There is. Not terribly useful because there's other ways to get around doing it. But if we get time, you know, Thursday will be our unit test. If we get time before Thursday, I'll show it to you. Otherwise, I'll show it to you next. A side note, now that everybody's logged in, next week, Monday, I'm going to take my personal day. This is will extend Easter. Next week, Monday, there won't be any class. Give you an extra day to finish up the test. So this one right here, for now, can't solve it until we learn that law of cosines. Let's look at case 4. Now I'm going to call it case 4A because case 4 has to be split up into 2 possibilities. So I give you two sides and one angle opposite side. And the side opposite the angle is longer than the other side. I'll show you in just a second why that's important. So if I give you that angle B is 32 degrees, and side B is 41 millimeters. Side C is 36 millimeters. I'm going to start out drawing my triangle. This is going to be angle B here. This is going to be side little c. So we know this is 36 millimeters. Draw in angle B here at 32 degrees. There is absolutely only one way this can be 41 millimeters over here. This up here has to be angle C, this has to be angle A, this would be side B. Yes, this is an obtuse triangle. This angle here will be obtuse. Now we can go ahead and we can find angle C. 41 millimeters over sine of which angle? Equals, we got the 36 over the sine of first thing that's a little more difficult here is once we cross multiply and divide, we're not done yet. Because cross multiplying and dividing here is not going to give us the angle, it's going to give us sine of the angle. So let's do the cross multiply and divide here first. We have the sine of 32 times 36 divided by 41. Get 0.4653. Now notice I did not clear my calculator. I'm leaving that in my calculator because I'm going to need that here in a bit. Sine of angle C is 0.4653. So to find angle C, I have to do an inverse sine. Rather than type that back into the calculator, I leave it there because there's a lot of digits past the 0.4653. So I'm going to do second sine or inverse sine. Second answer, telling the calculator to look at that previous answer and use it. giving me 27.73 degrees. Angle C up here is 27.73 degrees. Now that makes sense. 36 was smaller than 41, so 27.73 is smaller than 32. Now we find side A here, or angle A, I should say, by our simple subtraction. And 20.27, I believe. Now we can find side A by setting up the same proportion. Still 41 millimeters over sine of 32 degrees. Side A over the sine of 120.27. Now this is just like what we did in the previous examples. Cross, multiply, and divide to find the missing side. Giving us 66.82. .82 goes here. Now, we've done the double check where the longest side has to be opposite the longest angle. There's another double check that you can run on these to make sure you haven't screwed up. That's the two shortest sides have to add up to be larger than the longest side. 36 and 41 adds up to 77. That's bigger than 66, so that's okay. If you ever get that where the longest side is so much bigger that the two smaller sides don't add up to that or larger, then it can't be a triangle. If you had that one longest side, those two shorter sides, they wouldn't reach each other. So here was the case where we had two angles, one angle and two sides, but the side opposite the angle we were given was the longer of the two sides. That's the easy possibility. So for B, the other possibility is we have two sides and one angle. That angle is opposite one of the two sides. But the side opposite the angle order of the two given sides. When this happens, there are a couple of possible abilities. One gets really ugly. The other requires us to know some additional information. If I tell you that angle C is 29 degrees, and that side C and side B is when I draw this triangle out, you see that the side opposite my angle is the shorter of the two given sides. This is going to be side little b down here, 32 millimeters. Angle C at 29 degrees. There are two possibilities here. That 18 millimeter side could be right here, or this side could keep going. If that side keeps going, I have 18 millimeters up here. 18 millimeters could either be the purple or the green. Obviously, I didn't draw them exactly to scale, but you get the picture. So this angle here, which is going to be angle A here, could either be acute or obtuse. Don't know which. Right? Kind of difficult. Angle B here could either be obtuse or acute. Don't know which. So this requires us to solve this because angle B is going to be the first one we find. We need to be told whether angle B is acute or obtuse. I'm going to tell you that angle B is obtuse. So that means we're looking at this case here, the bigger, not that one. Wrong one. Looking at this case here. Angle B is the obtuse angle. Angle A is going to be acute. So now we'll set this up like we always do. You got C is 18 millimeters for the sine of angle C, which is 29 degrees. The only other piece of information that we have here so far is 32 millimeters. That'll be over the sine of angle B. Now we're going to cross multiply and divide to get the sine of angle B. Times the sine of 29, sorry, 10. 32 times the sine of 29. Divided by 8. 0.8619. That's the sine of B. So B itself is going to be the inverse sine. 0.8619. Second sine, second answer. 59.53. You see the problem there? We said that angle B was obtuse. 59 degrees obtuse. Yeah. But remember, on our unit circle, there are two angles that have the same sine. This is 59.53 degrees. We have that sine right there. Over here, there's an angle that has the same sine. It has a reference angle of 59.53. How would we find the actual angle? 80 minus 59.53. 120.47 degrees. It is the supplement. Remember, that's one of the problems with sines, is an angle and its supplement have the same sign. So when we know that angle has to be obtuse, after we do the inverse sine, we have to find the supplement of what it is that the inverse sine gave us. Because there are two possible angles, the calculator is only going to give us the acute angle. So we know that B up here is 120.47 degrees. I don't have room to write it in, but there we go. Now we can find angle A. Take 180, our angle sum, we subtract the 120.47, or subtract 29, what do we get, 30.53? A is 30.53 degrees. Now we can find side A by doing our proportion again, just like we've always done. It's nothing, I'll stop there, that's easy enough, right? So if we know, if we were told that angle B was acute, how would that change this calculation? Angle B would have just been the 59.53. Knowing that it was obtuse, we had to subtract that from 180. That is the single most common mistake people make with law of sines, is the angle's obtuse, but they get that answer and they just assume that the drawing is wrong and put in the answer. Instead of making sure that that really is obtuse. That is one thing. You can either be told it's obtuse or acute, or you can have a drawing where you can look at it and see that it's obviously obtuse. The ones that get difficult is where it's like either like 87 or 93 degrees, where it's really close to a right angle, and it's hard to tell, is it slightly smaller or slightly larger? Then you might need more information. in a situation like this, where, again, we have one angle and two sides. Again, the opposite side, smaller than the two sides. That opposite angle, smaller than the two sides. We just set this up as 43 millimeters over sine of 34 degrees. 100 millimeters over the sine of A. Now I realize we're supposed to go figure out whether A is obtuse or acute first whenever this case comes up, but something's going to happen here where it really doesn't matter. Sine of 34 degrees times 100 divided by 43. 1.3004. Anybody see a problem brewing there? That's bigger than 1. If I try to do an inverse sine here of 1.3004, my calculator is going to tell me to get bent. Can't have a sine bigger than 1, can we? But this is saying what's happening here. We have this 100 millimeter side here, side A. Here's our angle B of 34 degrees. What it's saying here is that's 34 degrees, 43 millimeters is not long enough to reach from this corner back to that side. No matter what direction it goes in, it's not going to reach. The most ideal, the shortest distance would be to go at a right angle. It's not even going to reach that. So this does not form a triangle. So that is that other unusual, hopefully you don't run into it very often case, that it's possible that it just doesn't form a triangle. If you end up with the sine of your angle, your missing angle being bigger than 1, then it's a roadblock. There's nothing. Like I said, tomorrow we will talk about the law of cosines. For now, you should practice this. There's a new packet out there. For those of you in the room, I'll give you the copy of the packet here as well. 81, 1 through 17, the odd.